Hi guys, so we are going to be going over lesson 3.2. You're going to need your textbook and let's get into it. So you're going to open up your textbook to page 181 and we're just going to talk about slope here. We're not going to fill out this graphic organizer for sake of time. So when we're talking about slope, we're talking about the rise or how much you're going up or down over the run. So the first thing people usually think about when we're talking about slope is talking about ski slopes. So on a ski slope, you could go up the mountain. That is your positive slope. Let's see if I can write faster with my stylus. Positive. That is your positive slope. Then you have a flat spot at the top, maybe you're going across, and that is a zero slope. Then you go downhill, and that is called a negative slope. Then if it goes straight downhill, I guess I could erase some of this and make it a little bit distinguished. That's a negative slope. If you were to go straight down, that is called an undefined slope. We will talk more about that later, but I just want to introduce the topic. I want you to write that in your notebook. If I can write undefined. Maybe make it look a little bit better than mine, but we'll get there. All right, so when you're talking about slope, slope comes into play in most real world situations. So this one is talking about a ride at an amusement park. I'm going to bet you we're talking about a roller coaster here. So it says it rises 8 feet, so it goes up 8 feet for every horizontal change of 2 feet. So when you're talking about your rise over your run, you are rising. Sometimes we call slope m. M is always the variable for slope. So here we are rising, we are going up 8. So in the numerator, in the top, we're going to write 8. In the denominator, it's how much we're running, how much we're going over, and in this case, we're going over 2. The last thing you need to do in these fractions is reduce them. So 8 divided by 4, or 8 divided by 2 is 4, and 2 divided by 2 is 1. And that is your slope. That's all you have to do for that one. It's on page 181. I'm putting the textbook page numbers right at the bottom here. You need them if you're ever not sure where I'm at. So when you're talking about slope, the most important thing to know, and I'm going to actually write in pink what I want you to write, and it's going to be just a little bit different than this. So slope, when we're talking about slope, we're talking about our rise, but the thing they exclude that I want you to include is that it's a rise or a fall. You could be going up or down over your run. Now your run is kind of like when you're reading a book. You always read it from left to right. So I want you to write a note to yourself. Run is from left to right. So I think when you're watching this video, I'm not sure which way it'll go, but from left to right, just like you're reading a book across. Just like you would read this from this side to this side, that's how you're going to always do your slope. Pause this video if you need to write it down, because I'm about to change slides. In this example right here, they give an example with a table. And in this case, you want to talk about your change in your y over your change in your x. This triangle that I just drew here is the symbol, the Greek symbol delta. And in math, delta is talking about change, how much the y is changing. So one way you can look at it is from 12 to 9, you're subtracting 3. So the change in y here is 3. From 1 to 3, you are adding 2, so your change is 2. And that's another way you can also get the same answer that they got here in your textbook. On page 183, there's some examples here. So in this case, we want to kind of count the boxes. When it gives you a graph like this, you're going to read it from left to right. So you're going to go across this, from this side to this side. So we're going to start at this point right here. The first thing I want to do is my rise or fall. Well, if I read it from left to right, it looks like we're going up. So it's going to be a rise. Let's count the boxes. We have 1, 2, 3 boxes. So we're going up 3. Then I want to know how much I ran, how much I went from left to right. So let's count those now too. So 1, 2, 3, 4. I went over 4, so it's going to be 3 over 4. And that is where our m equals, and that's our answer. For C, it's the same thing. You're going to do the change in y over the change in x. So let's set this up. The change in y, if you don't want to deal with negatives, and there are negatives and positives, you could always check out here. The change from 0 to 1 is +1. Pretty straightforward. Then from 2 to 6, we added 4. It's a terrible drawing there. From 2 to 6, we added 4, and that's our answer right there. Go ahead and try, I'm not sure if there are any more on this page, but make sure you're trying all the other examples I don't do in your notebook, or in your textbook, I should say. The last thing you need to know is a slope formula. So I want you to write in your notes, pull out your notes and write slope formula. And I want you to write just what I am writing in pink. So the slope formula is y2 minus y1. I'll talk about that in just a second. Over x2 minus x1. Then we're going to say x1, x2, no, sorry, I have it switched, which is exactly what I was going to caution you about. You have to be very careful. x2, x1, y1, and x2, y2 are 2 points. So x1, y1 is point number 1. x2, y2 is point number 2. That's the second point. And you'll see that kind of in the wild in just a little bit. I'll show you an example of that. So pause this video if you need to write this down in your notebook. I'm going to move on. So again, for these problems, you are going to find the slope, and the way you do that is figure out the change in your y over the change in your x. So here it looks like I'm still rising. I'm going up 1, 2. So positive 2, if it's positive, you don't have to write a positive, you can if you want to. Then I'm going to see how much I'm running. In this case, I'm running 1, 2, 3, 4. I'm running 4. The nice thing about 2 over 4 is I can reduce it by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And that is your final answer. You'll do the same thing for your other slope triangle. Go ahead and try those other problems on the page. The other one is with the table, like I showed you. I want you to give those a try. Figure out what your change in your y is. Figure out what your change in your x is. Pause this video to try those. I'm going to keep barreling on. The last one that I want to talk about is when you get 2 points. So when you have 2 points, like 0, I'm going to write it bigger just because I cannot write very small. 0, 1, that is your point 1. Then you have 2, 7, which is your point 2. So the first thing I want you to always do when you get 2 points is I want you to label it x1, y1. Be careful not to do what I did in the last example, which is that I started mislabeling them. So be very careful of that. Then we'll call this our x2, y2. Slope formula gave us this formula of y2 minus y1. That's the change in y over our change in x, x2 minus x1. How much each of those are changing. y2 is easy to find now because I wrote it right here. It's 7 minus my y sub 1, which I wrote right here, is 1. And then x sub 2, which is 2, I got it from right here. And x sub 1 is 0. So 2 minus 0, and that's how I get my slope. So 7 minus 1 is 6 over 2. I could reduce that by 2, and it becomes 3 over 1, and that is my final answer. I want you guys to try the rest of these. Tear page 185 out of your textbook and turn it in your packet, or you can always send a picture to me on Remind, on Google Classroom. You can email it to me however you want to submit it, but I would like you to submit that page just to show you watched this video. Thank you for watching up to this point. I hope you guys are doing okay. I know distance learning is not anyone's favorite, but I appreciate you guys watching my lesson. Try to keep it pretty short so you don't have to listen to me talk for, too long. At least not as long as our whole lesson. So, all right, see you guys. Have a good day.